Good day, class. In this lesson, we will study solving triangles. And this is part 1, where I will demonstrate an example of solving a triangle where there is one possible triangle given 3 measures. Okay, so keep in mind that there is a matter of ambiguity with this lesson where we're always going to have to check for one of 3 things. Do we have a triangle? And then also, if we have a triangle, do we have one possible triangle or do we have 2 possible triangles? So let's take a look. We are given this information. We're asked to solve a triangle when side A measures 5 units, side B measures 2 units, and angle A measures 50 degrees. Now, a couple of details there. Notice how I have lowercase letter a and capital letter A. So lowercase letter a means I have a side measure. Capital case letter means I have an angle measure. Also, it's very clear my angles here are measured in degrees rather than radians because I have a degree symbol. Notice also we're going to label our triangle sides. This is super important. It is a detail that is really crucial to understanding this material and accurately representing the sides and angle measures of your triangle. Here, I've labeled angle A opposite side A. Now, I could have used any of these corners to label angle A, but I definitely need to use the opposite side measure to represent side A. Recall that the capital letters represent our angle measures, the lowercase letters represent our side measures. I'll also do the same for B and C, and those can really fall anywhere, but there are some specifics that I kind of stick to make sure my details don't fall apart here. Now, I'm going to label these with the given information. Notice I'm going to choose angle measure 50 degrees is my angle measure A, and so the side measure A is going to be opposite of that 5 units. I don't know if this is 5 meters, 5 kilometers, 5 miles, 5 yards, 5 inches, whatever, it's 5 units. And so a problem, which is actually somewhat of a matter, or actually is a matter of ambiguity. This is why we discuss the ambiguous case or ambiguous cases when we're solving triangles. There's so many we're going to take a look at, but specifically here, you'll see that we'll be dealing with the law of sines, and the reason we'll be dealing with the law of sines. But even so, we first need to determine, do these measures constitute a triangle in the first place, with a side measure A, a side measure B, and an angle measure A. And so notice here, I have this correspondence, 50 degrees and 5 units in length for my side A. So that's nice. I know as soon as I have this correspondence, side opposite angle, then I'm probably dealing with the law of sines. And so we'll look at in a different lesson how the law of cosines might be helpful when we don't have that correspondence. So at any rate, the matter here is that I don't know if I really have a triangle. Notice how if I have side B, an angle measure B, I've been given this information, side measure B, but not angle measure B. And I don't know what a side measure C and angle measure C, but I do have enough information to calculate the remaining sides and angles if I actually have a triangle. Here's the deal. If the height of this triangle is taller than that measure of 5, then my triangle won't close. Notice how, or imagine yourself in a situation where you're building something, you're constructing something, and you've been given parameters, and you have to connect maybe your plywood on this 50-degree angle. And one piece of your plywood is 2 meters long, the other piece of your plywood is 5 meters long, and you have to stick to this 50-degree angle measure. Well, the question becomes, will your triangle actually close if you're trying to achieve a triangle? And that's super important to know, because if that line, that height there that I've built, the height that you see, which is by dropping a perpendicular line from that upper vertex down to the side measure C, if that is taller than measure 5, okay, then I don't have a triangle. My triangle won't close. So it's going to be important for me to check. So I'll do that. For example, if this height is 20 units, then there's no way the triangle would close. Now, obviously, this height isn't 20 units if we do the calculations But even so, just to kind of exaggerate a little bit and show you, if that is as tall as 20 units, there's no way that 5 is going to reach down to the corner and close to create a triangle. Recall that triangles are polygons, which means they are closed-sided figures. So let's take a look. Algebraically, we can determine the height of this triangle, because it's true that by definition, the sine of an angle measure is opposite side measure divided by the hypotenuse. So this is true. If that's true, by definition of the sine of an angle regarding right triangles, remember the sine, that function regards a right triangle. We have a right triangle here. We simply need to identify our height and our opposite measure, which happens to be the height of the triangle, and our hypotenuse. And so we've done that here. We have the sine of 50 degrees is whatever's the height of this triangle divided by the hypotenuse measure. We can calculate here, multiply on both sides, 2 on both sides of the equal sign, and we discover that 2 times the sine of 50 equals the height of this triangle. Remember, if you're using your calculator for this, make sure your calculator is in degree mode. How do I know immediately to go into degree mode? Because I see the degree measure in my given information. So I'm changing my calculator to degree mode. Push mode on your calculator or whatever kind of calculator you have. Find the mode and change from radian measures to degree measure. And then I put that in my calculator, 2 times the sine of 50, and the calculator knows to read that 50 as 50 degrees and not 50 radians. And so now I can discover that it looks like my height is sufficiently short enough to constitute a closed figure. Notice how the height is 2 units. That means that 5 is long enough to reach down to the bottom, or approximately 2 units. We calculated 1 point something. So it closes. I definitely have a triangle. Now I can move on and find the remaining side and angle measures. Also, I need to be thoughtful here. Do I have 1 triangle or do I have 2 triangles? Super important, because as we'll discover in the next lesson, depending on the measures you're given, if you're building something, I don't know what you could be building, maybe a doghouse or something, and you have these parameters where you have to have a certain angle, you're given certain length plywood, well, there are 2 ways in which you could set up your plywood to create a triangle for some given measures. And then for other measures, there's only 1 way to create a triangle. The way we determine that is we compare the 2 given side measures. In this case, the side measure that is opposite the given triangle is a larger measure than the side measure adjacent to the given angle. When that side measure opposite of the given angle is larger, it's a bigger measure than the other given side measure, then we certainly have 1 triangle. So I'm going to prepare to apply the law of sines looking for 1 triangle. Notice here, the law of sines is A divided by sine A equals B divided by sine B. Now, we have all 3 in sequence here. C divided by sine C is also equivalent, but remember to use the 2 that are relevant to whatever problem you're dealing with, whatever situation you're working in. Apply your logic. We'll use 2 of these at a time to create a proportion. Notice here, I've labeled up everything I can. Don't really need that height anymore. I know that I have a triangle, that this triangle closes, but even so, I have my side measures labeled up, and I need to calculate any other given measures. I'm going to use A sine A equals B sine B, because this is the law of sines that says I can find, given 3 of these 4 measures, and I have 3 given, I'll substitute them all in, and then I'm missing 1. So notice how I'll solve this proportion. It is a proportion. We have 2 fractions contained with an equal sign contained between them, so their cross products are definitely equal. So we'll multiply on that diagonal, or cross multiply, and then we will divide both sides, in this case, by 5. Now we have sine of B on the left side of the equal sign. To get the B by itself, we're going to take the inverse sign. Remember, the inverse of any function, a function and its inverse composed of one another, produces, leaves you with the variable. So here, we're going to take the inverse sign of both sides to keep our equation in balance. With that, I know on the left hand side I'm going to end up with the B, and on the right hand side I'm going to end up with 17.8 degrees is the measure of my angle. Notice how in my calculator I'm using the inverse sign, which is above the sine key, which in my example, in my calculator, is a yellow key. So I'm going to activate my yellow keys, click on that sign, and then it gives me inverse sign. And then I'm going to understand whatever kind of calculator I have and carefully use my parentheses or my numerator denominator features to make sure I put this into the calculator effectively. Now I know the measure of angle B is approximately 18 degrees. Make sure you pay careful attention to the fields and the requirements for your fields. Practice that I'm working on, my angle measures were I was asked to round to the nearest whole angle measure. So now I can label that up. Looks like there's only one, there are two measures that are missing, angle measure C and side measure C. Well, angle measure C is pretty simple to find because we know that the summation of those interior angles of the triangle should make up 180 degrees. So we'll subtract the 50 degrees and the 18 degrees already used, which leaves us with 112 degrees. So now I have a single measure remaining, side measure C. So I can handle that just as I handled finding the other side, the other missing measure using the law of sines. In this case, I'm just going to isolate side measure C, leaving me with 5 sine of 112 degrees divided by 50 degrees. My calculator can handle this. Make sure I understand how to use it effectively. This time I don't need inverse sine. I just need sine based on reading my the formula I have here for the law of sines. And then I discovered that side measure C has a measure of 6.1 units. And the triangle has been effectively solved where all side and angle measures are revealed.